So let's take a look at these individual types. So let's pick a variable, we'll call it n, and pick an integer to store into that variable. And we can see that when we look for the value in the variable, it's still stored there, right? And we can place a new value in that variable. There we go. Python allows us to confirm the type of that variable. And it even allows us to see how much memory is being taken up. So this variable n is using 28 bytes of memory in order to store that int. Let's see what happens if we have a float. So let's have a float of 28.5 whatever. Okay, so we can also look at that value and we can check the type of that value. Okay, and we can also print the value, and you can see that looks exactly the same as if we just type it. But so when you're using print to represent our value of x, it's not necessarily showing all the numbers that are in the computer's representation of it. It's just showing the most significant of the figures that it thinks you want to see. So if we format the x, look at, let's say, 20 significant figures, we see actually that there's these extra 9s in here and 8, 9, 7, so on. The computer, using a binary representation, can't exactly match the 0.598 at the end. And so it's getting a number that's very, very close that just rounds the 0.598. And so if we look at the number of bytes that it takes to do that, we can see that it's only using 24 as opposed to 28. So let's look at a more extreme version of this. So I'm just going to, need to have this all numbers. Just really long, big old number here. Okay, if we ask the computer to repeat that number, you can see for yourself, match the numbers, it goes all the way down. It's the same. So let's see how much memory the computer is using for that. So it's using 56 bytes to represent this integer. Okay, so we're going to set x as very related to n, but now it's a float because we multiplied it by 1.0. That 0.0 is telling us that the product of this should be a float. This is coercing the type of this expression into a float instead of an int. So let's just see what the value we get is. So now it's using scientific notation, and if we just look at the numbers that we can see, well, even at that point, we can see they're not right? So we have a 2, 3, 1, 7, 8, 9, 4, 8, 7, 6, 4, 3. The next number should be a 3, 4, 3. We got a 4, 4. We can keep on looking at it, the format. And we see that the number continues to be off of the same value of n. And the reason for that is it's still only using 24 bytes to represent this float. So integers scale in Python. The amount of memory necessary to represent them just keeps on growing so that you can keep on storing larger and larger integers. So in Python 3, there's not actually a largest integer size that you can represent. That's different than some other programming languages. But with floats, there is a limit to the precision that you can get. if we look at the binary representation of our n, you can see it's a whole lot of ones and zeros to get there. So those are two of our types. So let's look at the other types. We also have strings. So we can say a string, our variable string is equal to hi there, people. And we can just type the S, but we can also say print S. And notice we get the same thing, but without the quotation marks. Right? This allows us to insert special characters. So we can say, hi there, people. And I've put two special characters there, right? Special characters usually have an escape sequence, that's a backslash. So there's a backslash T, and there's a backslash N, and if we just look at S, it just copies exactly what I typed in there. But if I print S, then we can see that backslash T becomes a tab, and the backslash N becomes a new line. And then finally, we have booleans, which represent true-false values. So we can say that boolean equals true. Just look at the boolean. More commonly, we store the result of a conditional in there. So we can say that 4 is equal to n, right? So in the parentheses, I'm asking with this double equal, is 4 equal to n? And we can see that is false in that case. We can ask, is 4 less than n? And we see that it's true. We can also ask, n less than infinity. And we see it's true there. We don't actually need this variable, by the way. I was just storing it somewhere, but we can get the Boolean value just by itself. Since Python is not too concerned about whether the type of a variable changes, then we can start with one type of variable and have some sort of mathematical operation change the result into something else. And this is known as typecasting. So for example, we know that we have a type of just a plain old 2 and a type of 1.0. Right? If we have x of 2 plus 1.0, and say we print x, the type of x is a float, because that 0.0 precision level is sort of added on to the value of x. Same sort of thing, right? What if we have a 5 divided by 2.5? 5 is an integer, 2.5 is a float, and so the precision of that division gives us a float as the outcome. But if we have a 4 divided by a 2, 4 is an integer, 2 is an integer, so the outcome, since it divides evenly, so even if we have two integers, 4 is an integer, 2 is an integer, but we divide, so we're going to get a float as the output. But, I mean, you know the answer is exactly 2, right? So this isn't like chemistry where there's sig figs in this case. Those are two integers. The answer is exactly 2. So what do? You can do what's called integer division. So you use a double division sign. Now you get an integer as the outcome. But you need to be careful with this, right? Because what is 5 integer divided by 2? It's still 2. This is always going to give you an integer as the outcome. Specifically, it gives you quotient without the remainder. So if you do 10 integer divided by 3, you're going to get 3, and so on. What about strings, right? So 3 is an integer, But if I want to include it with a string, what I can do is concatenate. So let's say I've got, say, x is equal to hi there, and then y is equal to Pauline. Then I can print x plus y, and this plus sign doesn't mean I'm adding the values, it means I'm concatenating the strings. I'm putting one string after the other string. I can almost do that with numbers as well. So let's say I have x is 3 now, right? So I'm assigning 3 to the integer, I'm assigning 3 to the variable x, and I try to do print x plus y. Okay. Now the problem is I can add an integer and a float, and I can concatenate a string with a string, but this plus sign means two different things to these two variable types. So I kind of have to tell it what I mean here. And so the most straightforward way to do it here is to say, oh, well, I would like you to convert this integer into a string and then concatenate them together. So this is sometimes this deliberate change of a type of variable. It's called typecasting sometimes. And so it starts off as a number, turns it into a string. There's another way to do that. This is my favorite way to do that. So we say print, and inside here we do, every time you have a variable you want to put the value in, you put curly braces. So I'm going to say the first variable goes there, and then the word and the second variable goes there. Okay, and then out here you do dot format, and then there's two parentheses, and then inside there you can put your two variables. So if you don't do anything else, the first variable will go to the first curly braces, and the second variable will go to the second curly braces. There are more details you can do, but now it knows where to stick those in. Play around with this, see what some other operations you can do, right? So you can do 3 times 8, right? 3 times 8.3. You can also do powers pretty easily. Use the double asterisk for that, so 3 to the 3 would look like that. Order of operations works when you're doing operations, mathematical operations. So 3 times 8 plus 1 does the 3 times 8 first, and then the plus 1. And 3 to the third times 8. Let's do times 8 plus 1, right? 3 to the third, let's make one easier to calculate in our heads. So 3 gets squared first, then multiplied by 8 plus 1, just like you would expect from your PIMDAS rules from math. All right, so go play around with those, and then next time we'll start scripting our Python commands.